إذا الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome one and all to another bumper episode of K-Way Mathematics. I'm your host and presenter, Muhammad Kota from the K-Way Mathematics Institute here in Johannesburg. As per usual, on our daily slot, we're now preparing the grade 11s and 12s for the final examinations in 2015. We stopped yesterday, or we stopped in our last episode with calculus. We're now going to go, we ended off with differentiation. So just to quickly recap what we did in our last episode, we started with first principles in calculus. We then did the derivative. We did differentiation. We did limits. We're now going on to finding the equation of a tangent to a point, the cubic graph, and optimization. So like we said the last time, grade 11s, you don't need to know any of this. But if you are paying attention, you want to up your skill, no problem. Pay attention and get with the program. We're now going to start with finding the equation of a tangent at a point. So the question in the exam would state, if f of x is equal to 3x squared minus 2x, find the equation of the tangent to f of x at x equal 4. Question like this in the exam, 5 marks. Answer. Now, what we need to do here, boys and girls, is that we need to understand what is happening. We have a parabola, right? 3x squared minus 2x is a parabola. So just to give you a rough indication as to what we're talking about, there's a parabola that's passing that looks like that. That's just a very rough sketch. At the point x equal 4, there is a tangent passing that. At the point x equal 4. They want the equation of this tangent. Now we know that the tangent is a straight line. And the equation of a straight line is given by y is equal to mx plus c. Okay? What do we need in order to get, for y is equal to mx plus c, y is equal to mx plus c, what are the two major components that we would require in order to get this equation? We'd need a m value, which is a gradient, and we'd need a c value, which is your y-intercept. Those are the two crucial components that we would require in order to get that equation. So, let's get started on how to. This here is just to give you an illustration as to what is going on in the question. They say, if f of x is equal to 3x squared minus 2x, find the equation of the tangent to f of x at x equal 4. Now, step number 1, I'm going to give you a copy and paste process. Let's start with step number 1. We got an x. We need a y. We don't have a y. Now, if the x and y was given, you wouldn't need to do step number 1. But because only x is given and we need to find y, the first step that we're going to do is take this x value, plug it into here for every x to get our corresponding y. So now we're going to say f of 4. f of 4 is equal to 3 into, for every x, I'm now going to substitute 4. 3 into 4 squared minus 2 into 4. This is equal to 4 squared is 16. 16 times 3 is 48. Minus 2 times 4 is 8. 48 minus 8 is 40. That means my coordinates at the point where x is equal to 4, y is equal to 40. Now we've got an x and y. Again, I'm going to repeat. If the x and y was given, we wouldn't need to do first step. But because only x is given, we substitute x to get our corresponding y. Okay, now we need to find the gradient. And I told you guys from the start that the word calculus means gradient. So, we want to find out the general gradient on that parabola first. So we now, what do we use for general gradient? We're now going to use f dash x. So f dash x is equal to, we're finding the derivative of the original to give us the general gradient. This here is going to give us the general gradient. So the general gradient on f of x is going to be, we're going to be using derivative 2 times 3, 6x minus 2. 6x minus 2. So therefore, the m of your tangent, your specific gradient, right? Your specific gradient is going to be, so we can write the m of the tangent, or we can say f dash 4. Doesn't make a difference. So the gradient of your tangent is going to be 6 into, we've got an x value here which is 4, 6 into 4 minus 2, 6 times 4 is 24, 24 minus 2 is 22. So now we've got the m value. We've got the m value. We now need to get the c. Remember, from y is equal to mx plus c, y is equal to mx plus c, we now got the m value. We now need the c. So what did we do? We found the derivative. Step number 1, find the derivative. Step number 2, take the x value, plug it into the derivative. You now get the exact gradient. That means you now have 22x plus c. So we've got our m value. We're only short of c. Now we want the equation of the tangent. Therefore, the equation of your tangent will be given by, now you know when one pair of coordinates is given and the gradient, we can go into the formula grade 12, y minus y1 is equal to m into x minus x1. Right? And then we remove the brackets and we get it into the form y is equal to mx plus c. So y minus y1, we're going to be using the point 4 and 40. So y minus 40 is equal to m, which we got 22, into x minus 4. Remove the brackets. Y minus 40 is equal to 22x minus 22 times 4 is 88. So y is equal to 22x minus 88 plus 40 will give me minus 48. And there we go. That is your final answer. That is the equation of your tangent. Y is equal to 22x minus 48. Okay, so step number 1, we substituted x in here to get our corresponding y because we need x and y. We then find, so we can call this, let's highlight that, step number 1. Step number 2, the general gradient. How do we find general gradient? We use the derivative, yes. Number 3, we find the specific gradient. From the derivative, we substitute the x in there. We get the exact gradient of the tangent. Step number 4, we now go into the equation of the tangent. It's done in 4 steps. Boys and girls, a question like this is worth 5 to 6 marks in the exams. Please make sure you know this. Okay? Let's erase. Let's do one more and let's see whether you can do it. I'm now just going to change the values. I'm now going to give you another parabola. I'm going to say minus 6x squared minus 2x at the point P, let's say 1 and 3 for 5 marks. Let's see if you can do this one on your own. Okay? I'm going to erase this and let's work out the memo. One more example, and that is done with finding the equation of the tangent. That means this topic now is now done. We're then going to go on to the cubic graph. Okay, so let's see. We've got an x, we've got a y. Do I need to substitute the x in here to get the y? No. So I can go directly into derivative. I can say f dash x is equal to minus 12x, 2 times minus 6 minus 12x minus 2. Therefore, the m of my tangent, therefore, the gradient of my tangent is going to equal to minus 12 into 1 minus 2, which is equal to minus 12 minus 2 minus 14. Therefore, your equation of your tangent is now going to be given by y minus y1 is equal to m into x minus x1. So we have, which point are we using? Again, we're using the point 1 and 3. Y minus 3 is equal to m, which we found, minus 14, into x minus 1. So y minus 3 is equal to minus 14x plus 14. Y, final answer, y is equal to minus 14x plus 14 plus 3 plus 17. And that, boys and girls, that would be your final answer. We're now done with finding the equation of the tangent. We're now going on to the cubic function. Now guys, the cubic graph, the graph is worth 12 marks. We're going to do the forward and the reverse. We're going to be doing how to sketch the graph, and then if the graph is given, how to then find the equation of that graph, of the given graph that's given. We're also going to be doing what you guys all know by now, the point of inflection. And many of you still don't know what that is all about. So let's erase this and let's go on to the cubic graph, the cubic function. Okay. Now, some background knowledge about the cubic function. Let's start. So put the heading, the cubic graph. Now we know that the standard form for the cubic graph is f of x is equal to x cubed plus ax squared plus bx plus c. Sometimes they might give it to you like this. Sometimes they might tell you that f of x is equal to ax cubed, where your a value will change, plus bx squared plus cx plus d. Boys and girls, these two are exactly the same. It's just in the first one you can assume that the coefficient of x cubed is 1. Here the coefficient of x cubed would be a different value. It could be a value greater than 1, or it could be a fraction. Just to show you guys, before we cut for an ad break, what the shapes of the graph would look like. Because it's cubic, it's got 3 x-intercepts, but not necessarily. So here are the 3 scenarios. If this is positive, the graph could look like that. 1, 2, 3 x-intercepts. That's positive. If it's negative, the graph could look like this. That's with 3 x-intercepts. Sometimes it might have 2 x-intercepts. So this is just here to show you the shape. So if it's got 2 x-intercepts, for a positive graph, it might look like that. And for a negative graph, it might look like this. If it's got only 1 x-intercept, that's a negative graph. The positive graph would look like that, with 2 turning points. That's the positive, and the negative graph would look like this. Okay, so there we go. What I'm going to do is quickly, before we cut for an ad break, I'm going to put up a problem here on the board. Let's see if you, the viewer, if you, the grade 12 learner, can do this in 3 minutes during our ad break. So I'm going to give you a question, and I'm going to ask you to sketch the graph. F of x is equal to x cubed plus x squared minus 5x plus 3. Go ahead, it's worth 12 marks. Sketch that graph. When we get back, we will do the memo.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back from our ad break. I left you with this question before the break. I asked you to sketch the graph f of x is equal to x cubed plus x squared minus 5x plus 3. Now boys and girls, these are not just examples, these are templates. I want you, like we always say, I want you to master these templates, because these are processes that you need to follow. Now, in order for you to sketch a graph, let's take this graph for example. Let's erase this. Like I showed you before the break, these were just the shapes in which the graphs could look in your final answer. So if you get any one of those shapes, you know you're right. Okay. So here goes. What do we require in order to sketch this graph? We need a y-intercept. We need x-intercepts. Like we said, 3 intercepts, 2 intercepts, or 1 intercept. And we need 2 sets of turning points, which in calculus we don't call turning points. We call them SPs, stationary points. So let's go into process and procedure. Right. In your answer, the first step that we do is we say let x equal to 0. So if x is equal to 0, because we want our y-intercept, so we got 0, 0, 0. What is y equal to? Y is equal to 3. That means we now got our y-intercept. We're now short of our x-intercepts. Now, boys and girls, we're now going to be doing a system called synthetic division. Now, maybe at your schools, you might be doing long division. Your teachers might tell you, take the one factor that you found. We're going to use the factor and remainder theorem and synthetic division in order to find all our intercepts. If you don't want to use that, you're welcome to use your calculators. Now, I'm not going to name the brand of this calculator, because we might be conflict of interest here live on air. I'm going to hide the brand, but I'm going to show you the calculator. So I think you all know what that calculator looks like. It's got a solve key on it. You can find your x-intercepts using the solve key. So we're going to go mode. You can go equation number 5, and it's got ax cubed plus bx squared plus cx plus d. You can then plug in all your values, and guess what? You're going to get it. You don't need to show all those processes. But I am going to show you the manual way in which to do it. So in case your calculator decides by some miracle in the exam to bomb out, you at least know how to do it manually. Okay, so like I said, get this calculator. 99% of you in this country know what this calculator is. Okay, get this calculator. It will help you to factorize. It will help you to get your x-intercepts. You don't need to actually go and do this entire process. But in any case, let's go back to it. Let's say we're now going to try the factor and remainder theorem. We're going to try f of 1 to find our x-intercepts. we're going to try 1, 2, minus 1, minus 2. Whichever one gives me 0 as a remainder. Remember, for a number to be a factor, it must have 0 as a remainder. Common sense. Take the number 6. The number 6 has many factors, but let's choose 2 factors. 2 and 3, or 3 and 2. So 2 goes into 6 how many times? 3 times. What's the remainder? 0. So therefore, we can then conclude that 2 is a factor, or 3 is a factor. Why? Because it's got 0 as a remainder. So for a number to be a remainder, it must have 0. For a number to be a factor, it must have 0 as a remainder. So let's try f of 1. We're now just going to try random f of 1. So we're going to go 1 cubed plus 1 squared minus 5 into 1 plus 3. This will give me 1 plus 1 minus 5 plus 3. 1 plus 1 is 2 plus 3 is 5 minus 5 is 0. What do I notice? That 1 is my first factor. So that means if 1 is my first root, therefore x minus 1 must be the first factor. Why? Because x minus 1 had to equal to 0, x would have equal to 1. So now we got our first x-intercept. How many intercepts are we short of? From the highest power, from 3 intercepts. How many am I short of? 2. Okay, now we're going to do what we call synthetic division. So let's do this. I'm just going to lift this board slightly up here. Let's now go on to synthetic division. Watch this. We now take all our coefficients. What are our coefficients of the original? 1, 1, negative 5, and 3. I'm just going to put this as a blue one, so you'll know where I'm going to plug that one. Okay, that blue one is going to go here outside. Okay, so whether you do it this way, or let's do it the other way. I'll show you even a shorter method than that. Let's do this. This is the shortest humanly possible way to factorize a cubic. So we've got our first one there. Let's put the 1 there. So we know the blue one, that was our first factor, we pull it out there. All these coefficients will now go underneath your division sign. So I got 1, 1, negative 5, 3. 1, 1, negative 5, and 3. I pick up this first one, always. The first letter, the first number here, the first digit, you bring it up. Now when we come down this way, we're going to multiply. Whatever answer we get, we're going to add it to the next term. So it's going to be multiply, answer, add to the next term. Multiply, answer, add. Multiply, answer, add. So we're going to follow this process throughout here. So let's multiply. 1 times 1, 1. 1 plus 1, 2. 2 times 1, 2. 2 negative 5, negative 3. Negative 3 times 1, negative 3. Negative 3 plus 3, 0. You must get 0 at the back. So now, if I took out one factor from here, I'm left with a square. So this must be 1x squared plus 2x minus 3. And there we go. That is your trinomial on the top. Your quotient is your trinomial. Let's now factorize the trinomial. So now we've got that. We factorize that equal to 0, x and x, 3 and 1, plus and minus. We now have x plus 3 equals to 0, x is equal to negative 3, or x minus 1 equals to 0, x is equal to 1, or we've got x minus 1, our first one, x is equal to 1. So if you've got x is equal to 1, x is equal to negative 3, or x is equal to 1. So basically we've only got 2 intercepts, negative 3 and 1. So this is a cubic function with only 2 x-intercepts. So let's just go through this process again. Some of you might not have got it the first time. Let's quickly go through it again just to show you how it's done. Okay, so here we go. And what did we say? We call this synthetic division. So we take the first one there from outside, the blue one, our first factor. We put it there. We put all our coefficients inside, 1, 1, negative 5, and 3. We take up the first one. We multiply. Whatever answer we get, we add. Multiply, add. Multiply, add. Multiply, add. So 1 times 1 is 1. 1 plus 1, 2. 2 times 1, 2. 2 minus 5, minus 3. Minus 3 times 1, minus 3. Negative 3 plus 3, 0. That's your trinomial. 1x squared plus 2x minus 3. Factorize that. X, 3, 1, plus, minus, equal to 0. X is equal to negative 3, or x is equal to 1. And there we go, boys and girls. We now have our y-intercept. There's it. We have our y-intercept. We have our x-intercepts. In this case here, we don't have 3. We've only got 2. So we know that the graph, because this is positive, we know that the graph is going to look like that. It's going to have two x-intercepts. So this is what that shape is going to ultimately look like at the end. So now, we've got our y-intercept, we've got our x-intercepts. What are we short of? Our turning points. And what do we call turning points in calculus? Stationary points. And this is where we use, obviously, it forms part of calculus, so we must be using the derivative. So now let's go and get our x-intercepts. So don't worry about this. Remember, the shape of the graph is only going to appear or emerge right at the end. Okay, we now go on to SPs. So I'm just going to move over here to the side just to get our SPs. So that was step number 1. That was step number 2, the factor and remainder theorem. Then we had synthetic division. Step number 3. We're going into step number 4 for SPs, stationary points. This is where we're going to be using the derivative. Okay, now we're going to be finding, that's the question. So that's the equation. Let's find the derivative of that. So f dash x is equal to 3 times 1. So we're going to have 3x squared plus 2x minus 5. And what do we know? For minimum or maximum, the derivative is always equal to 0. Why? Because if we have this, there's a straight line passing. What is the gradient of a straight line? 0. So at that point, your derivative is always equal to 0. So let's now find, so we make the derivative equal to 0. We factorize that equal to 0. You can use any method now to factorize, making sure you get the correct factors. 3x and x, 5 and 1, plus minus x is equal to minus 5 over 3, or x is equal to 1. We've got our two x values, minus 5 over 3 and 1. We are now short of our two y values. So we take this and we plug it back into the original, not back into that. So we say f of negative 5 over 3 is equal to, if you take minus 5 over 3 and you plug it in here, minus 5 over 3 cubed plus minus 5 over 3 squared minus 5 into minus 5 over 3 plus 3, you're going to get 9,48. So your first answer is that, and 9,48. And then you're going to try f of 1, and we know f of 1 is 0. And then we're going to put that as 0. Okay, boys and girls, we're now going to cut for an ad break. We found the derivative. We made the derivative equal to 0, found two x values. Take each of those x values, plug it back into the original, get your corresponding y values. Now you can go, during the break, we're cutting now for a short ad break, sketch the graph. When we get back from the break, I'm going to put up the graph, and let's see how correct you were. Okay, so enjoy your break.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back to the K-Way Maths Show. Before we went for the ad break, we did a problem here where we had to sketch the cubic graph in calculus. This was for grade 12s only. We said f of x is equal to, that was the question. For 12 marks, you had to sketch the graph. So this was all the calculation. Let x equal to 0, solve for y, factor and remainder theorem to get your first factor, synthetic division to get your quotient, take your quotient, factorize it, you got your two x values, your x-intercepts. We then went on to SPs, and that's where we used derivative. You always use derivative for your stationary points. Whenever we're talking about your turning points or your stationary points on a cubic function, we're always talking about the derivative. So we use the derivative, we make it equal to 0, factorize the derivative, we get our two x values, take each of these x values, plug it back into original, not back into here, otherwise you'll get 0. Put it back into here, we get our corresponding y values. Let's now sketch the graph. Now I told you guys during the ad break, sketch the graph and let's see how well you do. So let's put the graph down, let's see what the graph is going to look like. So we've got that, y is equal to 3, y-intercept. So we go 1, 2, 3, y is equal to 3. X is equal to 1, x is equal to 1, or x is equal to negative 3. There we go, negative 3. So negative 1, negative 2, negative 3. There we go. Those are our two x-intercepts. Turning point, minus 5 over 3. Now minus 5 over 3 is minus 1,6666, which is minus 1,67. Now that's minus 1, that's minus 2, that's minus 1,5, minus 1,66 should be there. So that's about minus That's negative 5 over 3 and 9,48. So that should be the point. So let's put it down. Minus 5 over 3, 9,48. That is your first turning point, and we put a dotted line. We put a dotted line through your x value, and now we've got 1 and 0. Now 1 and 0, not only was it your x-intercept, it is now also the turning point of the graph. So now we put another dotted line going through 1 and 0. Let's just put it here. That's the point 1 and 0. And now we join the dots. Now it's a positive graph, so it goes from the bottom up. So let's draw the shape of the graph. Let's do it in a different color so that you can see it. We start at the bottom. It goes increasing, 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 increasing until stationary point, and which is a turning point. Changes direction. Decreasing, 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 cuts through there. Supposed to cut through here, but it's also a turning point. Normally the graph would have went down and went up, but it's also the turning point. So it turns here and continues up. So it's increasing from negative infinity up to minus 5,3, and this is an exam question. For which values of x is the graph increasing? It's increasing from negative infinity. So let's write it in a different color. All right. So it's increasing. It's increasing from negative infinity up to negative 5 over 3. That's the first point where it's increasing. It's also increasing because it's increasing here. Remember, this is the journey. This is the path of the graph. It's increasing, increasing up till there. Now it's decreasing from negative 5 over 3 to 1, and it's increasing again from 1 to positive infinity. So from 1 to positive infinity, it's increasing. Where is it decreasing? Where is this graph decreasing? The graph is obviously decreasing between these two x values, because the question will say for which values of x is the graph increasing or decreasing. So all we do now is it's decreasing from minus 5 over 3 up to 1. Both of them excluded. We cannot put included because those are your stationary points. The values of minus 5 over 3 and 1 are excluded. Okay, so that is how you would interpret the increasing and decreasing component of this function. Okay, so that was how to sketch the graph. Let's now do the reverse. What if the graph was given and you needed to find the equation? Okay, don't worry about point of inflection. We will get to point of inflection when we are done with this. I will do some graph interpretation and show you exactly what all these graphs mean. Now, this is a very important calculus, like I told you from the start, so important. It's worth 40 marks in the exam. You can score full marks for calculus, but you just need to know what you are doing. So, let's start. I now give you a function. So, forget about that now. I now give you a graph. Okay, let's put a graph here and let's take a random graph. I tell you that is minus 4, this is 1, and that is 2. Okay, I tell you this is graph f, and I tell you that f of x is given by, x cubed plus ax squared plus bx plus c. You need to find a, b, c. Basically, for 6 marks, what are they asking you? They want the equation of the graph. Okay, you know you've seen this. Now you get 2 scenarios, guys, only 2. You get one where 3x, remember when we did functions and we did parabola in our previous episodes, we said that if 3x, we had 2 scenarios. We had one where x-intercepts were given and one where turning points were given. This is exactly the same what's going to happen here. When x-intercepts are given for the cubic function and where turning points are given for the cubic function. Okay, so let's get started. We now need to find out what is the equation of this graph. So that's your question in your answer. What's given? Are my turning points given? No. What's given? My x-intercepts. Good. So now we just say f of x is equal to x minus x1, x minus x2, x minus x3. x1, x2, x3. So this is equal to x minus 4 plus 4 into x minus 1 into x minus 2, remove the brackets, we're now going to get x plus 4 into, multiply this out, you can FOIL it, x squared minus 1 minus 2 minus 3x plus 2, and now first times all, second times all, collect your like terms. So x times x squared, x cubed minus 3x squared plus 2x plus 4x squared minus 12x plus 8. Collect your like terms, x cubed minus 3 plus 4 is plus 1x squared, 2 minus 12 minus 10x plus 8. That's A, that's B, that's C. So A is equal to 1, B is equal to -10, and C is equal to 8. So although they didn't give you the C value, they could have asked you also to give the coordinates of D, X, and Y. So obviously, where are you going to get D, X, and Y? X value here is 0. Where do you get its Y value from? You're going to take its Y value from there, the Q value. Okay, so let's just go that way. That's your Q value, or that's your C value. And there we go. So obviously, this here would be 8. Okay, so all we do, we plug in all those values, remove all the brackets, collect all your like terms, and you will get your final equation. F of x is equal to that. Now comes another scenario. This is just if 3x intercepts were given. What if 3x intercepts and a point was given? Okay, this is worst case scenario in this type. So let's see what happens there. So now I give you 3x intercepts and a point. So now we go here, give you a graph like this. I tell you that is minus -3, that is 1, that is 2, and I give you the point here P, 4, and 6. Now I tell you this equation is given by f of x is equal to ax cubed plus bx squared plus cx plus d. Find a, b, c, d. So now we know that there is a coefficient in front of x cubed. Why is there a coefficient? Because another point is given. So now we cannot go and use that formula, that same formula. So in our answer, so this is the question. In our answer, we now say f of x or y, let's start with y, is equal to a into x minus x1, x minus x2, x minus x3, right? We're now solving for a. There's x, there's y. There's x, there's y. Here are all your intercepts. We're going to cut for an ad break now, boys and girls. I want you now to try. You got 3 minutes to try it. Find your value of a. Take a, plug it back into your original equation, expand and collect all your like terms, and let's see whether your calculations match up with ours at the end after the ad break. Okay, boys and girls, please make sure that you understand all these processes. If you need more intensive training on it, please make sure that you purchase our set here. We've got a complete 12-disc set that covers the entire grade 11 and 12 syllabus comprehensively. Okay, the price and the product and our email address, everything is on screen. Please make sure you call in or you send us an email.
الأمجاد قد عظمت فللأمجاد بانيها إذا الأمجاد قد عظمت فللأمجاد بانيها.
Boys and girls, welcome back from the ad break. Welcome back to the K-Way Math Show with me, your host, Mohammed Kota from the K-Way Math Institute here in Johannesburg. Now, we cut off before the break giving you this question here saying now determine the equation of this function. Find a, b, c, d. It's worth about 10 marks. So let's get started. We got y, there's y. This is x, that's y. So now 6 is equal to a. I said we're solving for a. X is 4 minus 3 plus 3 into 4 minus 1 into 4 minus 2. We're now going to be solving for a. So 6 is equal to a into 4 plus 3 is 7. 4 minus 1 is 3. 4 minus 2 is 2. 6 is equal to 7 3s are 21. 21 times 2 is 42. 42a. So a is equal to 6 over 42, which is equal to 2 goes into there 3 times. 7 6s are 42. 6 goes into 6 once. 6 goes into 42 7 times. A is equal to 1 over 7. Okay, hope you all got that answer, grade 12s. Now take the 1 over 7. That's not your final answer. We're now going to take the 1 over 7. We're now going to take the 1 over 7. And we're now going to plug it into there. So we've got now y is equal to 1 over 7 into x plus 3 into x minus 1 into x minus 2. Yes, it's a lot of work. That's why they're giving you 6 to 8 marks, right? Now multiply all that out because you need a, b, c, d expanded, without the brackets. So we got 1 over 7 into x plus 3 into, now let's do the back portion first. We got x squared minus 1 minus 2 minus 3x plus 2 which is equal to 1 over 7 into, let's multiply all this out. Yes, it's again I'm telling you, it's a lot of work. First times all, second times all. So we got x cubed minus 3x squared plus 2x plus 3x squared minus 9x plus 6. Collect your like terms. 1 over 7 into x cubed minus 3x squared plus 3x squared will cancel out. Plus 2x minus 9x minus 7x plus 6. Now multiply the 1 over 7 inside. So I'll get my final answer, y or f of x. F of x is equal to 1 over 7x cubed minus, now that's over 1. 7 over 7 is 1x, so minus x plus 6 over 7. So this is your a value. A is equal to 1 over 7. B is your coefficient of x squared. There's no x squared here. So b is equal to 0. C is your coefficient of x. C is equal to negative 1. D is equal to 6 over 7. There we go, boys and girls. You will get 6 to 8 marks for that. So we plug in the coordinates. Put in all your values, we solve for a. We take a, we throw it back into the original equation without the x and y, expand all the brackets, collect all your like terms, expand it again, and that is your final answer, a, b, c, d. Okay, now this was scenario 1, which was broken up into two components. One where we can assume that the coefficient of x cubed is 1 when no point was given, and one where a point is given, so we now need to find our a value. Okay. Let's now do scenario 2 before we wrap up the cubic graph. Let's do scenario 2, and scenario 2 looks like this. Now what happens in this case when the stationary points are given? So now they don't give you the x-intercepts, they give you let's see, they give you a c value here of 1, a y-intercept here of 1. They give you this as minus 2 and 20, and they give you this point, this turning point here as 6 and minus 4. Okay, they tell you that the graph is given by f of x is equal to x cubed plus ax squared plus bx plus c. Find a, find b, find c. Okay, 10 marks. Find a, b, and c. That's your question. This is your answer. Right, I'm going to show you a method of attack, boys and girls. Okay, so let's just turn that a little down. We've got our c value already. There's our c value. C is equal to 1. So immediately we can go and we can say c is equal to 1. Why? Where do we take it from? From our y-intercept. If it's not given, not a stress. We still know how to do it. I'll show you how it's done if the c value was not given. Okay. Now we got our two stationary points. So what I want you guys to do in the exam is just make a line down your page. So we're going to do, because this year we're going to be working with simultaneous equations. Okay. So we cancel out the two y values because we're not going to be working. Remember what I said earlier, derivative deals with x. We're not interested in the y's. So step number 1, we're now going to find the derivative of the original. So we're going to say f dash x is equal to, let's look at this. What do we have? 3x squared plus 2ax plus 2ax plus 1 times b is b. The c value will fall away because normally when we have an equation and we find the derivative, the constant value falls away. So we're left with 3x squared plus 2ax plus b. And we do know that derivative at these stationary points are equal to 0. So now you can say sp1, sp2 because you've got two stationary points. Now, we've got 3x squared plus 2ax plus b is equal to 0, and we got 3x squared plus 2ax plus b is equal to 0. We've got two turning points. We've got one where sp1 where your x value is negative 2, you got sp2 where your x value is 6. Now, we now substitute the minus 2 for every x. So we got 3 into negative 2 squared plus 2a into negative 2 plus b is equal to 0. So this is 4 times 3 is 12, minus 4a plus b equals 0, minus 4a plus b is equal to minus 12, divide by negative 4a minus b is equal to 12. We call that equation number 1. We now do the same on this side. We go 3 into 6 squared plus 2a plus 2a into 6 plus b is equal to 0. 6 squared is 36. 36 times 3, 108. 108 plus 12a plus b is equal to 0. So 12a plus b is equal to minus 108, and we call that equation number 2. Now I got minus b plus b. So whether you want to do it by substitution or whether you want to do it by elimination, it's entirely up to you. I'm going to do it by elimination because it's so much easier. So I'm going to take equation number 2 and I'm going to copy and paste it here. So I have got now 12a plus b is equal to minus 1 over 8. That's equation number 2. Why did I do that? Because I got a plus b minus b. I know the b's can go. So I'm going to add these two equations. So 12 plus 4, 16a, plus b minus b will give me 0. 12 minus 108 is minus 96. So a is equal to minus 96 over 16 is negative 6. There we go. Right, we got A. We now need to find the value of B. We've got C, we've got A. We now need B. We can take this and plug it into any equation. So now I'm going to say 4A minus B is equal to 12. I'm taking equation number 1. I've got A, negative 6. 4 into negative 6 minus B is equal to 12. 4 times negative 6 minus 24 minus b is equal to 12. Minus b is equal to 12 plus 24, 36. Therefore, b is equal to negative 36. Divide by negative, divide by negative. B is equal to negative 36. So we've got now, we've got A, we got B, we got C. What did the question say? Find A, B, C. Game over. Problem solved. So what would your final equation look like? Your final equation would look like f of x is equal to x cubed plus ax squared minus 6x squared plus bx, where's our b? Minus 36x. What's our c value? 1. And that is your final equation. Okay? Boys and girls, we're now going to be doing the point of inflection. They might ask you here on the graph to show your point of inflection. So let's now put what is your point of inflection. And point of inflection is your second derivative. Point of inflection is your second derivative. We've just been indicated that it is time for us to end the session. But stay tuned for our next episode where we're going to be doing the point of inflection and optimization in calculus. Boys and girls, ladies and gentlemen, brothers and sisters all over the world, I hope you enjoyed another explosive episode of K-Way Mathematics. We've got our DVDs here. Our address is on, our contact details. We've also got an institute here in Johannesburg. Please give us a contact if you or your child needs specific intervention at the best rates possible internationally. Contact us and we'll be sure to get back to you. Contact us, phone in or punch in the email address kwaymath@gmail.com. That's the only email address you need to know.
الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا